and I'm going to have to get into my Blackboard. I haven't been in it yet this morning, so it'll take just a moment for it to get there. Well, it's going faster than it did earlier. This morning I just sat and waited and waited and waited for the computer to respond, but this is going better now. Oops. I'm going to bring Zoom back up so everybody can see what I'm doing. I know y'all have been on Zoom, but I haven't. Okay, I'm going to do my screen share to show Blackboard. All right. Now, whoa, here comes Chance. Let me get him in. Or her, I don't remember. Chance is here. Okay. All right. Y'all can see my Blackboard here, right? Now for right now, I'm going to scoot Jemiah over just a little bit so I can scroll down and see if I can find the course. These are all courses of the last spring and summer. There we are, Math 112. For this fall, things were different appearance before. Okay, now where I'm going to go now is the weekly assignments and activities. I'm going to move this thing out of the way. It's going to come back in the way later, but it's in the way right now. You can't see it, but it's a toolbar, taskbar that's blocking. So you see weekly activities. Now, Shay, you're in the way. I've got to move you up to the top. Okay, you can't see that, but I can't see everything on the screen because Zoom puts some of your names there, and sometimes they block what I'm trying to do. So here's the down arrow key. You can't click on weekly assignments because there's no icon. So you go to the down arrow and click on that. Okay, there's week 1. Okay, I'm going to open week 1. Generally, you'd be opening the current week, except for things like this. Now, the overview and to-do list, basically, that's all past. The instructional materials, some things that are always there, I only put in week 1, and all the other weeks I say see week 1. So that's where this is. So I'm opening this now. I can't click on that because it had an icon and an underline. And here were the PowerPoint slides we used for week 1. There are the recorded lectures, the YouTube videos that contain every class that I've taught from this course at some time or another. Remember, earlier in the term, the school hadn't paid the bill to WebAssign, so they cut us off. So those would be from the ones I taught last spring. They're all out there, same book, same everything. But this is the playlist. It doesn't say play, but there's the word list in it. And you just have to go through that and find the section that you want to, that you're interested in watching. Okay. Now that's I was just showing you that because I don't show that anywhere but in this week 1. Here are the instructional videos that you may or may not find useful. Again, they're only listed in week 1. The handouts were the research paper instruction and locator card. I only put those in week 1, and I say in the other weeks, see week 1. There are no labs, but here it is. ETC, other materials, Cengage, and that I have been putting now /WebAssign class key. That's the one for this course. Lawson.al 2742-3133. That's the one for this course. So that should get you your ebook if you're on, what do they call it, Cengage Unlimited. It should give you access to the WebAssign. I think you also have to be either have purchased the book or be on Cengage Unlimited. Now anything past that, I'm no good whatsoever, because that's all student function from there on. I don't know how you go from here, but I do know that's your key, both for Cengage Unlimited or Cengage ebook or whatever, and it's also for WebAssign. That same code works for both. Does that answer your question? Was it Shamari? Or Shay? It may have been Shay that was asking. Shay, did that answer your question? Okay, I can't hear it if you're answering, so you're on muted, so I can't hear you. Maybe you can't hear me either. All right. Any other questions while we're here in Blackboard? So what I'm going to do now, I've got to move y'all out of the way again. So I'm going to, any other questions here in Blackboard? Oh, here's Janae coming in. Let me get her marked present. And I'll go out of Blackboard. Okay. Let me get, that was Janae who came in. Okay, Janae's here. All right. So let me go back to share screen, to a new share, and we're in 1.5 now. So let's go there. Okay. Now, we're recording. Any questions, other questions? I still didn't hear an answer. Shay, did that answer your question? It did. Okay, great. All right. Are there any others before we get going? Okay. I have noticed recently, and it's probably been going on all term, they've been putting a lot of student emails out that they put faculty on as well. Some of these I tend to want to put on like a Blackboard announcement or somewhere, but it's all going to you anyway, so I thought that's just, you know, extra, taking up more space and maybe hiding things that you really need to see, so I didn't do it. But please, folks, check your emails. There's lots of stuff out there. I know there was one fairly recently, sometime within the last week or so. My internet connection is unstable, so I'm going to quit. Okay, did I break up then? Yes. Okay, sorry about that. I got a little block on my screen saying my internet was unstable. I know it took me a long time to log in this morning, because even though it said I had 5 bars, and you probably can't see this, but I have 5 bars right now, and yet it says the internet is unstable. Well, this morning it would connect, but it wouldn't give me internet, so I don't know what's going on. It seems like it's more of an internet problem than our Spectrum problem, but I don't know. So anyway, what I was saying is, one of the announcements that came out in the last week or so, I believe, was about the Space Center tutoring services. Okay, and that is one. If I'm going to go at it from 2 angles here. If you feel like you need tutoring, it's there. Okay, check your emails and you can see how to get tutoring for not just this class, any class. But on the second thing, several of you seem like, in fact, most of you seem like you're really sharp with this stuff. I won't know for sure until I grade that first test, but you may consider being a tutor. Obviously, you've gone through 098 if you needed it, and you've gone through 100 if you needed it. So evidently, you're pretty good at math, okay? So there are students out there in 098 and 100 that probably could use you as a tutor. And I know that, I think that the, whoops, here comes Ivan. Let me let him in. Okay. Ivan's here. Okay, I'm going to check before we get too much further and make sure I've got everybody accounted for, because I've been on several different screens and not everybody shows up on the same one. So um, please consider tutoring. Let me just give you a little bit of, okay, Ivan, I think your phone's turned on. Okay, great, thanks. Um, Let me give you a little background from me. When I was even when I was in high school, I enjoyed tutoring. I liked math and sciences and other subjects, and I usually was tutoring some of my friends or others in the classes, okay? And then when I was in college, I really struggled, to learn it because I was from a small rural high school. They didn't really prepare me for Georgia Tech, but I was able to catch on to it. And then my sophomore year, I was in the dorm system, and I was a counselor, and I had students coming in, freshmen coming in for tutoring all the time. You know what? That's where I learned my math the best. Not just from sitting in the classroom. Yes, I learned things there. I learned a lot of things there. And not just from doing homework. I learned even more things from doing homework. But boy, if I wanted to really get to know that I understood the math, ask me to explain it to somebody else. Oh my goodness, that is when I really learned math. Okay? And other subjects as well too. So folks, it's not just benefiting somebody else, which it is, big time. And it's not just benefiting you in that they'll pay you for it. But you also get the other benefit of learning the material better. You will be way more confident in math once you have to explain it to somebody, and then suddenly lights will come on and say, oh yeah, this is what this means, So really do give it serious consideration. If you need tutoring, go for it. If you feel like you could tutor, go for that too. Now, it's not just the Space Center. There's also the STEM program. That's the Science, Technology, Engineering, and Math. That's what STEM stands for. If you're in any of those majors, Dr. Shawanda Thomas is head of that program, and she is recruiting students, not just to tutor, but to be a part of the STEM program. So if you're in any of those majors, any science major, any technology major, any engineering major, or if you happen to be a math major, okay, anything in those areas, that would be biology, physics, chemistry, those are the sciences. Technology would be computer science mostly, other things like that. Engineering, of course, any of the engineering majors, and mathematics or anything related to mathematics. So if you're interested, please contact Dr. Thomas, Dr. Shawanda Thomas, sthomas@lawsonstate.edu. She also runs a tutoring program out of the STEM lab. You don't have to be there in person. It can be virtual. She can explain all that to you as well. The third way you have to possibly be a tutor, the Student Support Services has tutoring. And they may be able to use some peer tutors there as well. And they have Student Support Service on the Bessemer campus and on the Birmingham campus. So you can go through. You don't have to be on campus. Again, it can be virtual. So please, folks, give that a shot. Now, here's one other question I have for you. Are any of you nearing graduation, like either this term or next term? Yay? You are. Wonderful. Have you already applied to graduate?
I haven't. I spoke with I think his name Darren Allen
Yes.
yesterday. I mean about 2 days ago.
Right.
Concerning my classes, but no, I haven't applied.
Okay. There is an email that came out within the last week or so, I think from either Records Office or from Miss Lori Chisholm, who is registrar in charge of the Records Office, encouraging students to apply if they're getting ready to graduate. So go find that email, follow those steps. There's like 2 or 3 steps you have to go through to, yeah.
I have a question about that. I know what email you're talking about, and it was talking about the fall. I didn't know if I could do it this soon because I'm coming out in the spring.
In spring. Okay, that's a great question to ask them. In the old system that we were in, they encouraged students to apply the term before they graduated. I don't know if Banner allows that. Banner is brand new to us this term, so I don't know if Banner does allow it, but ask that of the records office. They'll know exactly, if you tell them I told you that, they'll know exactly where I'm coming from, because they used to really encourage students to apply the term before they graduate so they can, everybody can review their records and let them know if they need to take anything that next term, the one they're going to graduate, before the term starts. So you don't wind up the last term and say, oh, I didn't know I needed that. Well, no, you can't graduate this term then. So that's why they were encouraging people to apply the term before. So check and see. Yeah, they're really pushing for fall because they're reaching a deadline on that one. But check with them and see if you can go on and apply for spring. I bet you can. But Banner may not allow it. I'm in deep water there. Okay, I don't know. Yeah. Okay. Right. Yeah. Yeah. He's the acting dean of students, so you were right at the top there. But if you want to get closer to the people on the ground, that would be Miss Lori Chisholm or any of the people in the records office. You can just send the email to records, that's with a S, records at lawsonstate.edu, and ask them that question. Or that email that you're talking about, respond to that email and say, I'm planning to graduate in the spring. Can I go on and start the process now? And I'm sure someone will get back to you. Good. Great questions, by the way. Great questions. All right. Bottom line, check your emails, keep on top of it. Now, a couple people came in while I was running my yap there, so I didn't catch everybody in the book, so I'm going to pause a moment here and make sure I do have everyone here. Okay, I know Ashford came in then, and I didn't get a chance to put him in the book. Quenisha I had, Anaya I had, I may have everybody else. I think Quenisha was one who came in, but she was coming back in. Shay I have, Chance I have, Dee I have, Diana I think I have, Ivan I have, Jakiria I have, Jemiah I have, Janae, Shamari, Tamia, Tommy, Tyler. Yeah, I think I have them all. Let's see, I should have 15 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Actually, I have 16 students, so one person must have had to check out, and hopefully that person will be back. Okay. So, any other questions or concerns before we get going on math? Sorry we've taken so much time, but I think these are important issues to bring up. Now, there was a sound. I don't know where the sound is coming from. Let me see if someone, oh, still 16 total. So, all right. We are in Chapter 1, Functions and their Graphs. This is the, in my mind, the most important chapter we hit, because this, if you remember the course description, the algebra of functions. Okay, so basically this is hitting just about every aspect of functions we have. We'll get into some new stuff later too, but this is hitting lots and lots of deals about functions. And right now we're in 1.5, which is analyzing the graphs of functions. And one of the things we analyze here is the increasing and decreasing functions, which we talked about last time. We're on page 53, top part of the page here, and this is the figure 1-37 in your book, 1-39 or 1.39 on the slide set. I don't know why there's a discrepancy there, but this shows several different examples of relative minima, that's the plural for minimum, and relative maxima, that's the plural for maximum. Okay, it's from the Greek. Here's a relative minimum. Why is it a relative minimum? Because at this point the y value is less than or equal to all the other y values close by. So that's a relative minimum. In other words, this value down here, they sometimes call this c, or some value here for x, if you go a little bit to the left or the right of that and take the y values at all those places, this one's going to be the least of all those. Now stay close, okay? Stay close. When you get up here, this becomes a relative maximum. Why? Because any of the other, this is say C or C1 or C2 or whatever you want to call it down here on X, go a little bit to the left or a little bit to the right, find those y values, and those y values are always going to be less than or equal to that one. So that makes it a relative maximum. Same relative minimum here, same relative maximum here. Same reason. Now, the way they've drawn this, the reason they say relative minimum is, look over here. That looks like this function's going to head south and keep going down. So these are not going to be absolute minimum. Obviously this one's less than that one, but they're relative to the area they're in. They're the least value. Also, oh, here comes Ivan. He's the one who went out and came back. I've already got Ivan here, I think. Yeah, glad he made it back. Okay. These are relative minimum, but it looks like the function doesn't even have an absolute minimum because it seems like it keeps heading south here. But neither of these probably the absolute maximum. This one's more maximum than that one, but in the area where they are, these are relative maxima. Okay, but it looks like over here this function just could keep going up like this and soon exceed this one. So you see, that's why we use the term relative. In their neighborhood, they're the biggest cats on the block, or the smallest ones, okay? But they may not be the biggest in the town, okay? That's a bad way to look at it. All right, any questions? All right, now for some reason it won't click and move until I'm... Now, trying to find this paragraph in the book. I can't see it. Okay. Excuse me. All right. Today's a little chillier than most days have been, so sorry about the sneezing. I cannot see this paragraph here. Yeah, it's the one right under the thing. Okay, I found it now. This is still top of page 53. I was trying to make sure I didn't skip an example. You will study a technique for finding the exact point at which a second degree polynomial, that's called a quadratic polynomial function, has a relative minimum or maximum. That's coming up at the first of the next chapter, I believe it is. Okay, but for the time being, you can use a graphing utility to find reasonable approximations for these points. Or there's another way. It's a little tedious, but you can do it. We probably will get into that later. Okay. Now, I knew they were going to skip this one. Here's example 5, and they've gone on to the top of page 54. Here's example 5 on the bottom of, or sort of in the middle of page 54. So let me go to the whiteboard. Okay, now I've still got to do some more maneuvering. This toolbar is now in the way. So you can't see it, but it's in my way, so I got to get it out of the way. And then my whiteboard is not the most convenient place for it because it's underneath your names from Zoom. These programs ignore each other and they don't always coincide well. Okay, so I've moved that. You probably couldn't tell I did anything. It says use a graphing utility to approximate the relative minimum of the function f of x is equal to 3x squared minus 4x minus 2. Now, if you have a graphing calculator, that's one device that you could use, any kind of graphing utility that you could get to. Your phones may do it. I don't know how to make mine do it. So since I don't have a graphing utility here, here's how I would approach it. Let's see if we can approximate or find out where there might be the minimum. So I'm going to just start picking some points. Let's say x equal, my favorite is 0. So let's do f of 0. The reason I picked it, it's so easy. That makes that 0, that makes that 0, that's going to be a minus 2. Now that's a fairly low number. So let's pick another one. The next easiest in my book is f of 1. Okay? And that would be 3, because 1 squared is 1, minus 4, because 4 times 1 is 1, minus 2, and that would be minus 6 plus 3 is equal to minus 3. Ooh, that's less than 0. So let's keep going to the right. Let's do f of 2. Okay? This takes a little more work. 3 times 2 squared minus 4 times 2. Now I could have written that for the others two, but they were so easy to do I didn't. But I'll write them for this one. Minus 2. So this is 3 times 2 squared, which is 3 times 4, minus 8 minus 3. Okay? This is 12 minus 8 minus 3. 12 minus 11 is 1. Oops! We started going up. So it looks like to me that the minimum is going to be somewhere between 0 and 1. Okay? Yes.
I'm following along, but where did you said 8 minus 12 minus 11?
Yeah. Okay. I went on and added minus 8 and minus 3 is minus 11. So 12 minus 11 is 1.
Okay.
Yeah. I should have done it in 2 steps, but I'm just lazy. I didn't want to write anything else down. You could have said 12 minus 8 is 4, minus 3 is 1. Any way you want to do that, that'll work. But you get 1. So it looks like the minimum is probably going to be between 0 and 1. Let's make sure the book agrees with that. Yep, they do. So if it's between 0 and 1, I'm going to try a value between 0 and 1. And that would be f of 0.5. That's certainly between 0 and 1. Now at this point, I can't believe I did this. I came upstairs without my phone, and my phone's my calculator. Do some of you have a calculator on you? It can be a phone or anything else. Let's do this. If you've got it, you do the work for me, because I don't want to do this in my head. That would be 3 times 0.5 squared, I know to be 0.25. Okay, so I am going to do it in my head, I guess. Okay, minus 4 times 0.5 minus 2. Okay, well this is 0.75, isn't it? And this is minus 2 minus 2. So this will be minus 4 plus 3/4, so that will be minus 3 1/4. I'm bouncing back and forth between decimals and fractions. Ho! That's less than either one of those. So now I'd say the minimum must be between 1 and 0.5. Looks like it, right? This was minus 3, that was minus 3 1/4. So let's pick something between 0.5 and 1. How about 0.75? F of 0.75. We're trying to get something in between this one and that one. because we want to come up with something less. So let's see if we can get something less. Now I believe it's about time for someone to pull out the calculators and do 3 times 0.75 squared minus 4 times 0.75 minus 2. So on your calculator, do exactly that. 3 times 0.75 and then find the x squared key. Press it. Minus 4 times 0.75 minus 2. Has anyone done those steps while I was calling them out? What did you get as an answer? Folks, you got to help me. I forgot to bring my phone up here today. Otherwise, I've got to go downstairs and get it. So, you going to make me do that? Or are someone going to do the calculating for me? Now, if you're on your phone, you probably can't do it. So, does someone have a calculator or a phone if you're on your computer? Can you do that? Anybody? So, y'all are going to make me go downstairs, aren't you? Okay. Well, hang on, Sloopy. I'm going to have to take off my headset because I'm wired in. And I'm going to pause the recording. Too many moving parts. Pause the recording here. Being charged. So, turning on my phone. And we go to calculator mode. Alright, now that's what comes up. Now that's your simple, cheap little calculator. It doesn't have a method for squaring on here. You could do 0.75 times 0.5. If you turn it sideways, this is an iPhone by the way, then you get more what I call the scientific calculator. Okay, so I'm going to punch in the numbers just like I said. I can't do them here because I can't read backwards. And I've got fat fingers and little buttons here, so I don't do it well. 3 times 0.75. Okay, now the square key you'll see is over here. You see x squared? So after I put 0.75, I press the x squared key minus 4 times 0.75 minus 2 equal. And there I get negative 3.3125. Okay, so let me get my Wacom back in my lap and write that down. This is negative 3.3175. Okay, this, remember, was negative 3.25. Okay, now both of these are less than this one, so one's out. Okay, no, I'm sorry. Yeah, one's out. So we're going to do something between 0.5 and 0.75. And this is the larger, the smaller number, the larger absolute value. So I'm going to do something closer to 0.75 than 0.5. So what you want to do? 0.65? F of 0.65. And you can do this as long as you want to. That'll be 3 times 0.65 squared minus 4 times 0.65 minus 2. Okay, so I'm going to do that again. Make clear what I had there before, just so I don't get it confused. 3 times 0.65 squared minus 4 times 3.65 minus 2 equal, hey, it even got smaller, negative 3.3325. So this is negative 3.3325. All right, so that's even less. Now it's between these two. And you can keep doing this as long as you want to, okay? Sometimes I call this the method of exhaustion. Until you get tired of doing it, say, hey, that's close enough. Let's just call it negative 3.3, okay? Because that rounded is negative 3.3. This is negative 3.3 rounds of that. This rounds of that. Let's call it negative 3.3. In your book, you'll notice they got negative 3.33, which this is awfully close to, okay? This one right here is awfully close to that. So that's going to be close enough, okay? They actually said on their graphing utility they got 0. The point was 0.67, which I bet you is rounded off, and this would be negative 3.33, which I'm guessing is probably really negative. I don't know this for a fact, but I'm guessing at it. If I can get my pen to work again, negative or positive 2/3 and negative 3 1/3, which would be 10/3. That's probably the exact answer. That's close enough in my book, okay? So if you don't have a graphing utility, and I don't know how to make my phone do graphing, I don't think it will, maybe it will, but I've not learned how to do it, then get your graphing calculator, or even, well, yeah, a graphing calculator would probably be what you would need. So any questions on that? There is a checkpoint. You can certainly do the checkpoint. In fact, I encourage you to do the checkpoints before you get too late in the after you've finished class. Now let's go to the next item in the section. Let's go back to 1.5. All right, we'll go back to current slide. Average rate of change. This is the top of page 54. I'll put this down for a moment. I'm not using it now. The average rate of change. Is this a new subject? Well, it has a new title, but guess what? It's an old subject. We have learned that the slope of a line can be interpreted as a rate of change. If you're going from here to there, your slope tells you that you're going positive, being it's up, but at a relatively slow speed, because that's not a very steep slope. That would be going really fast. This is going relatively slow. This is going backwards. This is going at the same speed, okay? So your slope of a line can be interpreted and is a rate of change. Now, this curve is not going at the same speed as that line. It's going faster here and slower here. In fact, it's going negative here. But between here and here, that's your average rate of change between this x value and that x value. That's on average how fast you are going. Even though here you are going faster, here you're basically constant, and here you're going negative to get back down to this point. For a nonlinear graph, that's what the curve is, the slope changes at every point. Right here the slope is somewhere in this direction, up here the slope is somewhere in that direction, up here the slope is flat, here the slope is going downhill, okay? So it's changing at every point. So what we want to look at is the average rate of change between any 2 points. Now we used to call them x1, y1 and x2, y2. Remember that? And we found the slope between y2 minus y1 over x2 minus x1. Guess what? Same deal. Same deal. Now, if this sounds like it's deja vu all over again, it is. What in the last section we were calling difference quotient, which was rise over run, here we're calling it average rate of change. So a difference quotient, average rate of change basically are the same concepts, but just for different applications. Okay?
So would you still be finding the function of it?
Yeah, well, there's a great question. Here is what it is. F of x2 minus f of x1 over x2 minus x1. Remember, what is f of x? Someone tell me.
The
No, x is your domain. F of x is your... That's the y. This is y2 minus y1 over x2 minus x1. That's a slope. The slope of that line is your average rate of change. The line through 2 points is called the secant line. That line right here is called the secant line, that light blue line here. Okay? And the slope of that line, they use M for slope. I don't know why they use M, but everybody does. And they put SEC here for not Southeastern Conference, but secant. Okay, the slope of the secant line. The average rate of change is exactly that, f of x2 minus f of x1 over x2 minus x1. You evaluate the function here, evaluate the function here. Basically, that gives you your y2 minus y1 over x2 minus x1. Change of y over change of x, that's your secant, slope of your secant line. That's the average rate of change. Same thing you did back in Math 100, may have even done it in Math 98. You probably, and you're doing it again here, slope. You did it in difference quotient. That was a slope, change of y over change of x. Okay? So, here's example 6. This is on the kind of the middle part of page 54. Find the average rate of change of this function, f of x equal x cubed minus 3x. And the first place we're going to do between x1 equal negative 2 and x2 equal negative 1. Okay? Now, let me get my Wacom board and my pen again, and let's see if we can work this in here. So this average rate of change, I'm calling it AROC, average rate of change, just to have something to call it. That's going to be f of x2, that's your y2, minus f of x1, that's your y1, divided by x2 minus x1. Change of y over change of x, slope. This is also called the slope of your secant line between those 2 points. Okay? So what we do here is f of x2 would be, plug in x2, which is minus 1 up here. So this will be f of minus 1 minus f of minus 2. This is x1, x2, x1. You know, the numbers are backwards. And this will be minus 1 minus a minus 2. Just plug and chug. Do what it tells you. So f of minus 1, that would be, plug it in right here. That would be a negative 1 cubed minus 3 times a negative 1 minus, now this I'm going to put in big brackets here. F of minus 2 would be negative 2 cubed minus 3 times negative 2. Now, I didn't write that well. I should put that in parentheses. Okay. I know it's getting into the thing here. Close out my bracket here. And all this is divided by, well, let's go on and do this. This is minus 1 minus a minus is plus 2. Okay. We'll get to that in a minute. Okay. Let's continue over here. Negative 1 cubed is negative 1. And minus 3 times negative 1 is plus 3. Okay. Minus, here's your bracket, negative 2 cubed is negative 8. And then minus 3 times minus 2 is plus 6. Okay? Over, and this came out being negative 2 plus 1, plus 2 is 1. So let's do the last part here. Negative 3 plus negative 1 plus 3, I can't talk, is 2 minus a negative 2, because negative 8 plus 6 is negative 2, over 1, and this would be a 2 plus 2. Didn't know we'd be doing such high-level math today, did you? Over 1, and that's simply 4. 2 plus 2 is 4. All right. Now, let's look at that secant line here. Between this point here and that point up there, ooh, look at that. Yeah, that looks like a really steep slope. I could easily believe that's a plus 4 slope. Now, notice what else. If I hadn't wanted you to do it yourself, I would have pointed this out to you, that f of minus 1 is 2. We could have just written that 2 in here, minus f of negative 2 is minus 2. There's minus a minus 2, and then minus 1 minus a minus 2 we did here as 1. But I wanted you to do your function because that's good practice. So there's our answer. The A part is a plus 4. Now the sad news is I can't erase here, but let's do what they say for the B part. And let's just try to condense it a little bit. F of 1, that would be 1 minus 3, so that's a negative 3, minus f of 0. Oh, I can do that one. Minus 0. Over 1 minus 0 is 1. That gave me a slope, average rate of change of negative 3. Okay, and sure enough, this one looks like that's pretty negative there. Now, did I do that wrong? I think that's a minus 2. Yeah. Duh, I was doing too fast. Negative 1 minus 3 times 1 is minus 3. Negative 1 no, I'm sorry, this is a 1. 1 cubed is 1. Minus 3, 1 minus 3 is minus 2. So this is a minus 2 here. Sorry about that. This is minus 2 minus 0 divided by 1 minus 0. Sorry about that. I'm going too fast. That is a negative 2. So here's a positive 4 slope here, a negative 2 slope there. Okay. Let's see how they did it. They probably won't make that same silly mistake. So here they did from the first. The x1 is negative 2. The x2 is negative 1. So f of x2 is f of negative 1 minus f of x1, which is negative 2, and divided by x2, which is negative 1, minus x1, which is a negative 2. So it's a minus 2. All right. Let's see. Okay. Let's go on and, just for practice, do that again. Remembering that your f of x is equal to x cubed minus 3x, wasn't it? I'm going from memory. I think it was. So this is minus 1 cubed minus 3 times a minus 1. Everywhere that you see an x here, you put that minus 1 in its place. Then you do a minus, and you put a minus 2 in its place. Negative 2 cubed minus 3 times negative 2. And that's all divided by x2 minus x1, which is this thing right here. Negative 1 minus a minus 2, so minus a minus is plus. Negative 1 plus 2 is 1. Okay? So this will be, okay, I'll let them go on from here. That gives them a 2, which is what I was going to say here. This is -1 plus 3, that gives them a 2, minus, and this will be a -8 plus 6, that'll be a -2, so -2 minus a -2 is 4. So this would be 4 over 1, which is 4. So we got the same thing. Average rate of change between x2 and x1, that's what that is. Between the next one, 0 and 1, this is going to be, remember your f of x is equal to x cubed minus 3x. So this is going to be 1 cubed minus 3 times 1 minus 0 cubed minus 3 times 0. Okay? All over, and I can do that subtraction, that's just 1. So this is going to be 1 minus 3 minus, this all comes out to be 0, okay, over 1, and this is -2. Okay, now -2 minus 0 over 1 is -2. The secant line there has a slope of -2, and for some reason right then I got really dizzy feeling. I don't know if I haven't drunk enough, I don't know. Man, that was a weird feeling. Alright, so there's example, yes. Is that someone coming in or leaving? Well, I'm on the wrong pad. Let me see. Well, someone must have left because we have now 14 students here. Okay. So let's move on to, oh, let me say this. Before you move on, there is a checkpoint. After every example, there is a checkpoint. If you can't figure out how to do the checkpoint, remember, you can go to LarsonPrecalculus.com and see an audio-video solution of that checkpoint. Okay, I think they do skip example 7. Let's see if they do. Yes, they do. So let me do example 7 on the whiteboard. Okay. All right, to clear this. So here's example 7. The distance S, now that's in feet. That's the distance in feet. A moving car is from a stoplight is given by the function S is equal to, and let's just call it S of t, function of time. S is distance, t is time, is equal to 20 times t to the 3/2 power. Now, time out a moment here. What does that mean, t to the 3/2? Does anyone know? There's one of two possible answers you could give, and both of them are correct. I guess you could give some that are not correct, but don't do that. The numerator means the power that you're raising it to. The denominator means the root that goes into it. A fractional exponent means you're doing a root. So you could think of this as t cubed, but the square root of t cubed. Or you could think of it as the square root of t, figure out what that is, and then cube that answer. So you can either cube it first and then take the square root, or take the square root first and then cube that answer. Either one of them will work. Now, Remember, the car was sitting at a stoplight, so at time t equals 0, the distance was 0. It was stopped, right? But 1 second later, it was now 20 feet away, because the square root of 1 is 1, 1 cubed is 1, 20 times 1 is 20. So 1 second later, it was 20 feet away. Now I'm not going to do 2 seconds because that's hard. I'm going to do 4 seconds. When t is equal to 4, the square root of 4 is 2. 2 cubed is 8. 8 times 20 is 160 feet away. So that guy is moving, okay? Moving pretty quickly, okay? So that's how we do radicals, radical exponents. In case you had forgotten that, that's what we do. Now, what we're looking for, this is the distance. What it's asking for is the average speed. Find the average speed of the car from, goodness, this drives me nuts. This is so ugly. The pen sometimes will write fast and sometimes it won't write at all. So this is average speed of the car from, there it went and did it again, from T1 equals 0, I've already told you what that is, to T2 equal 4, we already did this, to, yuck, T2 equal 4 seconds, okay? And then later we'll do it from 4 to 9 seconds. So the average speed, what's average rate of change or average speed? Distance over time. So the average speed is your average rate of change. The distance is S of T2 minus S of T1. That's how far it went between those two times, divided by the difference in time. Miles per hour, feet per second, whatever this will be feet per second, over T2 minus T1. Okay, so let's plug and chug here. Put T2 of 4 seconds in there. 20 times 4 to the 3 has power minus 20 times 0 to the 3 has power divided by 4 minus 0. Okay, now we already did that, remember? We did the square root of 4 is 2, 2 cubed is 8, 8 times 20 is 160. Minus square root of 0 is 0, 0 cubed is 0, 0 times 20 is 0. So it's 160 over 4, which would be 40 feet per second. So there's the average rate of, or the average speed between T1 and T2. Okay, all right. So let's do the next one, the average speed. This will be between 4 to 9 seconds. So that'll be S of, this is the B part, where T1 is 4 and T2 is 9. So this will be, I'll go to write, well, I've already written. So this will be 9 seconds minus S of 4 seconds. They were very nice to you, and then you do 9 minus 4. Okay? Well, we didn't do this one, so let's do it. I'll write it out. 20 times 9 to the 3 has power minus 20 times 4 to the 3 halves power divided by, I can do that, 5. Okay, 9 minus 4 is 5. All right, let's do this one. Square root of 9 is 3. 3 cubed is 27. So this is 20 times 27. Now we've already done this one, remember? Square root of 4 is 2. 2 cubed is 8 minus 160. We already did that one up here. Okay? Divided by 5. Now, I think I can do that one almost in my head. That would be 540. Is that correct? Okay, 540 minus 160 divided by 5, which would be 380 divided by 5, which I think would be 76 feet per second. Is that right? Yep. Yeah, 76 feet per second. The T didn't cross well here. Okay, there we go. All right, so there's how you do average rate of change. Function at 2 minus function at 1 divided by value at 2 minus value at 1. Change of y over change of x. Change of vertical over change of horizontal. And again, there is a checkpoint right after that. Please do the checkpoints. Now, if you have trouble doing the checkpoints, getting the answers they have in the back of the book or at larsonprecalculus.com, those can be things you can turn in as well. So let's go back to 1.5 and go back to the current slide. And that got us right down to even and odd functions. Now, what in the world do we mean by this? Okay, I think they're going to tell us. Would you not guess? Okay. You've studied different types of symmetry of a graph, okay, perhaps sometime in your past. In the terminology of functions, a function is said to be even when its graph is symmetric about the y-axis, okay? Now what that means, and then it's odd when it's symmetric about the origin, okay? That would be an odd function, okay? The symmetry tests yield the following tests for even and odd functions. Now, a function y is equal to f of x is even when for every x in the domain of f, of that function f, you plug in, instead of x, you put in minus x, and you do your f of minus x. See what you get. If you get f of x, if you get that same value, that's an even function, because an even function is the same on the right as it is on the left, okay? And what that means, if you go to the left and it goes up here, you go to the right and you go up here too, every time that's an even function. It's symmetric about the y-axis. However, a function y is equal to f of x is odd. If I could get my pen, there it is odd when for every x in the domain, your f of minus x. Notice all you do is plug in the same thing. But this time when you plug that in, if you get exactly the opposite of what you got when you put in a positive x, that means it's odd. So if when you went to the right, you went up here, went to the left, you went exactly the same distance but in the opposite direction, that means it's odd. Or when you went to the right, you went down, went to the left, you went up exactly the same amount, that means it's an odd function if that happens for every function, every value x. Now, they left something out here, and it's pretty important. There's a third kind of function, and that kind is called a neither function. It's neither even nor odd. If you don't get exactly f of x, and you don't get exactly negative f of x, it's neither one. It's not even and it's not odd. And in algebra, you're going to run into that a lot. When you get into trig, just about all your functions are even or odd. Okay, so but in algebra, you're going to wind up with a lot of neithers, and they didn't even mention it here. So here's example 8, and they did all the work for you, so I'm going to go back and we'll do example 8 on the whiteboard. Oh my goodness, we only got 2 minutes? How could it happen? Okay, so let's do example 8. Here's a function. Oh, let me clear the board. I'm not sure we're going to get very much done. Do you think? G of x is equal to x cubed minus x. Okay? Now, what's the test? The test is to see what g of minus x is. So let's see what that is. Okay, remember what we do? Everywhere you see an x here, you put a minus x there. So this will be minus x cubed minus a minus x. What's minus x cubed? Well, x cubed would be x times x times x. That'll be x cubed. And then with a minus, it's a minus times a minus, which is plus, times another minus, puts it back to being minus again. And what's minus times minus x? That's plus x. Well, look at this. This is exactly the opposite of this one. This is a positive x cubed minus an x. This is a minus x cubed plus an x. Those are exactly opposite of each other. That's minus g of x. So therefore, odd. Boy, that's odd, isn't it? That's an odd function. Okay? Now, we've just run out of time. Okay? Sorry about that, folks. We did have a lot of questions at the first, which I thought were excellent questions, so I'm glad you did it. So we did the A part. We'll start next time with the B part. Oh, and we came so close, so very close to finishing this section. My word. I wanted to be through with it, but we didn't quite make it. So homework exercises here would be either 7 or 9. They're both at Calc Chat. 9's at Calc View. Either 11 or 13. They're both at Calc Chat. 11's at Calc View. Any of the odds 15 to 25. They're all at Calc Chat. 25's at Calc View. Any of the odds 27 to 31. They're all at Calc Chat. Any of the odds 33 to 39, they're all at Calc Chat. 35's at Calc View. Any of the odds 41 to 47, they're all at Calc Chat. Any of the odds 49 to 53, they're all at Calc Chat. 51's at Calc View. Any of the odds 55 to 59, they're all at Calc Chat. 57's at Calc View. Either 61 or 63, they're both at Calc Chat. 61's at Calc View. And then look at 65, it's a Calc Chat, and either 67 or 69, they're both a Calc Chat. And you can start working on 71 to 75 if you would like. They're all at Calc Chat. 71's at Calc View, but we didn't finish that example, so if you want to hold off of those, you can. And we'll wrap it up next time, and this time we'll get into 1.6. Now 1.6 I don't think will take us as long, so I'm probably going to have your first test ready for you on Tuesday. I'll determine after class on Tuesday whether we got far enough that I can give it to you or not, and I'll probably put it out there maybe even in 2 places. One is as a message in Blackboard Messages, possibly also as the week assignment for week 6 next week. Okay? Any questions before we end it today? Okay, I'm sick and tired of sharing, so I'm going to stop the share. Okay, any questions on before I leave in the meeting? Any? Okay, take care, be safe, have a good weekend. But let me tell you folks, the virus is still going around. One of my students in my Cal 3 class has it. Okay, he's doing okay. He's not got a real bad case of it, but he's afraid he may have exposed his family, his girlfriend, because he saw him about a week ago. He hoping he didn't expose him. His roommate is taking care of him, but they're trying to stay as far apart as possible, so he may expose him as well. It's a dangerous thing. Be careful. Now he's doing well. One of my instructors, his son brought it home from school, didn't know it. The son was asymptomatic, didn't show any signs at all. The wife got it, and she is really, really, really sick. Okay, and it sounded like he was getting sick too. So it's hard to say, folks. Be careful. Have a good weekend. Take care.